Here we're going to look at percent error. Percent error is a lot like percent change. Percent change, we talk about the change divided by the original. Whereas for percent error, we're going to talk about the error, how much it's different, divided by the actual. So in both cases, you're subtracting to figure out the difference, and then you're dividing it by something to get the percent. So same idea, just a little bit different. So let's look at the first problem here. So we've got 320 and 227. It doesn't matter which one is which right now. We're just going to subtract them to figure out the difference. So 320 minus 227. Just going to clear this all off. 320 minus 227 is 93. So that's how much the error is. So that's the error, the difference. Then we're going to divide that by the actual. So the actual number was 227, so 93 over 227. And it says to find to the nearest percent. So we're going to round to the nearest whole percent once we divide these two. So 93 divided by the actual 227. That gives us about 0.409691, etc. So nearest percent, we're going to move this over twice or do times 100. Either way, it's the same. Oops. Let's fix that. Times 100 here. So 40.969163 yada 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 percent. So nearest percent would be 41%. Let's check our work here. And there it is. Let's try another one. I'm going to do one where it's a little bit of a rounding problem. So nearest tenth of a percent this time. So we've got our difference. We have 690 and the 448.5. So subtracting those two. I'm going to always subtract the bigger minus the smaller for these because you don't need to worry about negatives. We're not doing percent change where it's increase or decrease. We're just figuring out the difference. So the difference here is 241.5. That's how much the error is. And then we're going to divide that error by the actual amount. The actual is the 480 or 448.5. And then it says round to the nearest tenth of a percent. So 241.5 divided by 448.5. And let's see, so that would be 0.538. We don't need all these decimals, but we do need a bunch of them. I'm going to do times 100 here just to get it to a percent form. So nearest tenth of a percent would be 53.8 or 53.9. In this case, the number after the 8 is a 4, which means we're going to keep it an 8, so 53.8%. And let's just go back and check our work. There we go. So again, it's pretty straightforward if you know how to do percent change. It's just figuring out the error by subtracting them, and then dividing it by the actual amount, and converting that decimal into a percent. That's all you have to do to find percent error.